Alright, another DraftScience video presentation. As stated, for what purpose? Yes, who knows? Now, I could suggest that, the aliens someday might want to test you by, placing one of them among you and to see how you react, to the truth, let's say. Like they're giving you a test to see if the human race really can learn anything, or whether it's really, really stupid and it's just going to try to nuke anything that tries to change its little religion. Anything that opposes its God, whether the God is science or the God is Jehovah, you will just, tar and feather it and try to, And if it was an alien doing it, telling you there's no God, would you react insanely? So the aliens are saying, let's test these humans and see just how, whether they can be educated. Let's see if they're educables. Are they worth investing in at all? Or are they hopelessly stupid and therefore deserving of nuclear annihilation? Just, humanely put them out of their misery because they can't be educated. So if I was an alien, you are failing the test. I mean, not just a little bit. I mean, it's a gigantic failure of the test. Because you'll concede nothing. I mean, even when things are overtly wrong and stupid, you'll still sit there and say nothing, do nothing. No, I don't want to take any responsibility for that. I don't want to accept it. Anyway, so my last video just basically points out, look, no fault against Lewin. They all do it. All the professors cheat the truth. But it's clearly wrong to teach that the balloon, and I open the balloon, that there's an equal and opposite reaction. The air fights against being changed. It has absolutely nothing to do with the balloon. As I pointed out, I put the balloon in empty space. It does exactly the same thing. It has nothing to do with the balloon needing to push against anything or to have an opposite reaction from something. That's not where the opposite reaction comes from. The opposite reaction comes from the mere fact that you cut one of your arms off, you give it away, now you're lopsided, okay, and you tend to walk that way. I mean, it's that simple. There's no equal and opposite reaction. There's just the action of you giving away something and therefore having a deficit in the other direction. I mean, a deficit in the direction you gave away. And it means that the stuff that was already in you, equalizing your condition, is now no longer equal. That's just a simple fact, but it's a simple repair to a broken law. Newton was right, basically about a lot of stuff, but this one is just stated a little bit incorrect. It's just a little bit incorrect. It needs to be fixed a little bit, and you can't even accept that. You're so caught in your religion. I mean, so lost in the dogma every bit of the dogma has to be true. And in some sense it does. That's right, because you have created a religion that is dependent on all these players. Now, I would say there's parts of religion, if they just pulled it out, no one noticed the difference. You could pull the Holy Ghost right out of Christianity and no one would miss it, because it's not interconnected to anything. He doesn't have any functions. He doesn't have any jobs. But yes, a lot of physics you need your notions, because in some place you're completely dependent on the silly notion. And so this is where all this relativity talk, you always use that as a cop-out. All the things you try to evade the truth by claiming to try to fix what are just obvious errors. So anyway, I'm just saying, it's, the future's not going to look on you very well. It's not going to say, oh yeah, look how well they received the truth. No. You received it very badly. You showed no scientific discipline. You don't care about the evidence. And certainly you don't care about the truth, as Pyrrho just amplifies by saying, I don't care what physics girl says. Well, you're supposed to care. She's one of the science people. You're supposed to care what they say. I mean, jeez, it's just so stupid. Sorry, it's just really, really stupid. It's like a Catholic saying, I don't care what the Pope says. I mean, it's just stupid. Of course you care. All right, anyway. Now, of course you should. All right. So yeah, we'll do a couple of comments. That'll suck up a half hour, an hour, easy enough. Um, but the point is, look, it was a pretty good video explaining how it's just a subtle problem, but it fixes so much by understanding the difference between energy you possess, and how the world reacts to your energy. And just understanding that you have energy to give away. And if you give it away, you change who you are and what you're doing. It's just a fact. All right. Well, we don't need to draw yet. We'll read it first. No, you can't knock down pins forever. So obviously I made this analogy in a context. And I said, let's create a perfect world. Let's eliminate one thing, which is the friction between the pins. So the pins are here like dominoes lined up, hundreds and hundreds and hundreds of them. I hit them with a bowling ball going, who cares? It just doesn't matter. 1 mile an hour, 400 miles an hour. It's not going to make any difference. The fact is, when I hit the first pin, okay, it's going to be going almost as fast as the ball. All right, I'll be able to give it, say if I have 1 mile an hour, well, let's say I have 10, okay, just to make it you can see that, right? Yeah, you can see that. Just so we can see a number change. Well, the fact is the pin is just going to collect it. This is like I have 10 gallons of paint, and now I'm going to pour it into this bucket. This bucket can only hold, because it's, let's say so the bucket size depends on the mass. So if the mass here is 10, and this is, say, 5, the pin, all right, well, that means I can pour 5 into there, right? I can pour half of my energy into that pin. And so the bowling ball hits, it starts pouring the paint in, the velocity, all right, into the size of the bucket, all right? And so as it's doing that, it goes from 10 to 9, to 8 to 7. And then when it gets to 5, then the pin is now full. And the pin's going to be leaving now at 5 miles an hour. The bucket, the filler, is now down to 5 miles an hour. Right? Close enough anyway. For this analogy. With pins half the weight of the ball. Let's say it's, so it's going, the ball's going 5, the pin's going 5. And if we just say, okay, we didn't make any heat. We didn't create heat when we had the impact, the transfer. And often transfers will require some heat. That is, you're going to lose some energy in the other directions, as I've pointed out. Well, those are real losses to the environment. And so this number ends up being 4.8, and this number ends up being 4.9. Because the pin actually does leave the ball. It does actually stop getting filled because it's leaving. And that pin will hit this pin. And if I get rid of heat, the theory is there's absolutely nothing wrong with the theory that it can just keep doing this. If I don't make any heat, if I don't lose any energy in this direction, this conversion, if I don't convert this energy into another direction, it'll just keep hitting pins and doing exactly this. It'll just keep kinetic ball, like Newton's kinetic balls. Theoretically, okay, if it wasn't for the heat created, the little tiny losses, you could make the Newton's cradle infinitely long. You could swing a ball into this side and the ball will fly out this side. So that's all that was being proposed, is that all I have to do is get rid of a tiny friction bit, and a consequence of the interaction connecting to something, and the fact that there's a few little losses to the connecting process. I get rid of that little loss and the thing can go forever. So there's nothing to dispute here, Jerry. Now, I'll say about Jerry, look, the good news is this is at least somebody to argue with. He keeps changing the subject. He never concedes anything. But, at least he's stayed in the game, trying to defend this loop-de-doo physics. But, why do you need to change what I said into something else? It's just a fact. All right, so, and so he's going to relate this to the two trains. So let's understand what the problem with the two trains is. And again, I've said this over and over again, but apparently it has to keep being said. And because Jerry will just not acknowledge any facts. So you have the 5-ton train going 10 miles an hour. You bang it into another 5-ton train, all right, and now you have, and the two of them connect to each other in this case, okay, they just couple. You could just drop the weight. You could just drop 5 tons on top of this one. So there's lots of different ways you can change the mass from being one mass, 5 tons going 10 miles an hour, and then you'll end up with 10 tons going 5 miles an hour. So it's just like the example of the bowling pin in the sense of the transfer of energy. But anyway, that's what you're going to end up with. This one's going to stick to this 5-ton one. They're going to share the velocity, therefore reducing it to 5, and they're going to have the same momentum. Now, what you can't argue is that in this transfer, I completely transferred, I successfully reached 5. Now, I said the physics girl video should have at least conceded, okay, there'll be some losses. A tiny bit of noise and sparks will happen when this train hits this train. Okay, so you have a little tiny bit of losses. So, so instead of 10 miles an hour for the velocity, okay, the velocity goes to 4.8. Okay. But you can't say it lost half the energy, right? They're kinetic energy forms, so momentum is conserved. She said it clearly. The momentum was 100% conserved. Well, okay, that was unrealistic. Yes, you could say the momentum is 98% conserved. That's more realistic. I could show you real experiments where that's pretty much the truth. 95, 96% will be transferred. So they take a cart, they put the weight on it. Okay, so they change it to a 10-ton car. Okay, now going 5 miles an hour. Now their theory says, this stupid kinetic energy formula says this thing has, 10 squared 100 times 5. 10 squared is 100 times 5. Oh, and then times a half. Okay, so it's 500, so it's 250. Right? And they say that this card only has 125 of energy, joules. So they have the same momentum, and somehow they have these different joule numbers, this real energy thing. So somehow it lost 125 joules. Now they're saying that, oh, it deformed the car, and this happened, and this, well, no, that you can't still have the same momentum if you did all that stuff. You can't heat the environment and keep the momentum. You can't do two different kinds of work. You can't do work on the environment, that's real losses. That's gone. That energy is gone. When you make heat, it's gone. You're not getting it back. Realistically, this train can't make the conversion. It can't collect the heat back and say, I'm going to turn it into velocity. It isn't capable of doing that. So it's a real loss. And you can't have the same momentum. It'd be impossible. And so they're just not dealing with the real circumstance. It's not theoretically possible to take the energy, all right, turn it into heat, okay, 50% of it, and then pretend you still have the same energy over here. You can't still have the energy when you lost the energy here and here. You can't conserve it when you used it. You turned it into heat. It's gone. You've lost it in this system. The system doing this is now lacks energy because you gave it away. And you can't have the same momentum because the momentum is what's making the heat. I mean, it's just illogical. All right. Well, whatever. I mean, we've been over it so many times. It's just too silly. You can't. I've given you the analogy, Jerry. How are you going to undo the analogy? The analogy is that your velocity is like having paint in your bucket. You have a bias in a direction. You have a velocity. All right. If you pour your paint into another bucket and it now has the same momentum, that is the same amount of paint spread over in a bigger bucket, so it isn't high, but it's the same amount of paint. You can't say, well, I spilled part of it. I can't successfully transfer all of my paint and then say I spilled half of it. How are you defeating that in any way here? How is your argument in any way defeating that analogy? Oh, that's obviously not. All right. Okay. No, you can't knock down pins forever, which was the paradox you tried to illustrate. I didn't illustrate that as a paradox at all. What I was illustrating as a paradox is your notion that half the energy is getting lost somewhere, yet there's nowhere to see it. It's not a fact that it's lost. The momentum numbers show that it's not lost. So how can you claim it's lost? It's just ludicrous. Where are the equal and opposite reactions to all of that energy loss then? Where's Newton's third law if you're going to say its second law allows you to maintain the momentum and lose half the energy? If the second law allows you to do that, where's the third law? Because now we're back to the spaceship, and which way does it go? I shoot the dime out this way 1,000 miles an hour. I shoot the 2 kilograms out that way at 1 mile an hour. You're saying there's 1,000 times more energy going that way. Well, where's my equal and opposite reaction then? Because frankly, I'm not going to get that, right? I'm not going to see that energy converted into anything in terms of an equal and opposite reaction. It's going to be 3 or 4 joules that way, 3 or 4 joules that way. That's all it's going to be really going anywhere. So again, you really don't deal with any of these arguments. You just keep reciting from this Bible. Okay, of course the ball slows down. Well, of course in reality, depending on what you make, I've seen a Newton's cradle made out of real big steel balls, not bowling balls, but good sturdy stuff. And it really goes on for quite a long time, because the amount of energy, the heavier you can make these things, the amount of energy being stolen by the strings and the air and the kinetic hitting, the harder you can make them, the less and less that becomes, and the longer and longer the thing can keep going, because it's losing such a small amount of energy compared to the energy it has. All right. So I wasn't illustrating a paradox with that point. I was illustrating that momentum is something in the ball, and the ball gives it to the pins. And the fact is if it keeps giving to the pins in a good straight direction, the energy can go for a very long time. All right. Of course, the ball slows down at the same time the pin gains speed. So you're saying of course, but of course out of what? Out of its momentum. It's the only thing it has is its momentum. That's its energy. And you're saying because it's going faster that somehow it has more paint. It doesn't have any more paint. The speed is only a byproduct of how small the bucket is. Small bucket, high level on the bucket. Big bucket, small level on the bucket. Same volume, okay, of energy. Right? I pour the same quantity in a bigger bucket. It looks like less if I'm going to just measure how high it is. Okay, but it's not less. Okay? The 10-ton train going 5 miles an hour will light just as many light bulbs as the 5-ton train going 10 miles an hour. Are you disputing that fact? Do you really think inside your heart, I don't know where your brain is, but anyway, inside your ass, do you really feel it? It's correct to think that the 10-ton train going 5 miles an hour only has half as much capacity to do movement in the universe, to transfer energy to objects. Do you really think it's lost half the energy? You really believe that? All right. It's a system we are talking about. It's systems we are talking about where momentum moves. Yeah, the system is just saying everything's in the environment. And you're just saying, how long am I keeping the energy in the laser beam form? So I've used another analogy to make this so simple that we see energy because it's in things where it's going in one direction, and so it's group behavior. So if we see that, we see energy. But the fact is the energy just can go in all directions and then we don't see it. Then it's not visible to us. And that's a huge thing for us to be aware of, that the energy we see is the clumps going in one direction. We don't see when you break it into a million little pieces. So if I break the laser beam and spread it all over the place, you can only detect tiny little pieces of it in different locations because you don't have a detector that can detect all of it and say, oh yeah, it's all still there. Okay, so it looks like less energy when it's spread out, but it's not less energy. the light bulb and the laser beam, you could argue, have the same energy. It'd actually be a much less than a regular light bulb, right? A little dim kind of bulb has as much energy as the laser beam. It's just that that light's going everywhere, so it doesn't look very impressive, where the laser beam burns a hole through things. Okay, it's systems we are talking about where momentum moves from one object to another. Well, I mean, how, what's the point of talking about it? Again, have you accepted the fundamental premise that these are two different descriptions of reality? That momentum and kinetic energy cannot coexist. They have no coexistence. They are different descriptions of the elemental function of the universe. Okay, you can't have it both ways. You can't say that, I'm consistent with Newton's physics. No, it's not Newton's idea. It's not anything that Newton used to navigate everything in the universe. So don't keep claiming that Newton was using mv squared somewhere, because he wasn't. So this is a different physics attacking Newton's physics. It's the two are in direct conflict with each other. You ask them the same question, the two formulas give you different answers. You can't keep saying, that's compatible, that's good physics. It makes absolutely no sense. Momentum has no meaning if it isn't a description of energy. If it's not a description of energy, why are you even still using it at all? It makes no sense. Well, and the reason why you're still using it is because, yes, it's the only way you can make spaceships make sense. You can't make spaceships make sense. You can't use mv squared and navigate successfully. You have to use momentum. So that's why it still exists. Because, in the real world, space, the real environment, unpolluted by all the noise happening here on Earth, that in that real environment, mv squared doesn't mean anything. Anyway, where momentum moves from one object to another, but the total is the same, whatever that even means. So again, obviously, we don't have these perfect connections, so the total isn't always the same, because we lose a little bit with each interaction. The interactions are difficult. Now, you can make it cleaner, right? You can have all kind of rubber cushions on things so all the energy stays in the system going the right way because it's all absorbed in a very graceful way, and so you get much back of what you put in. You don't lose as much to heat. But yeah, we don't have as far as I know, you could think of using magnets between the balls, and that might, so if all the pins are magnetic, I could probably keep them falling for a much longer time, because I'm not going to lose much at all to the interactions. One pin is going to communicate with the next pin using a magnetic force that's incredibly efficient, that can't get hot. All right. Also, there is the mass to consider. So I don't even know what that could possibly mean when, duh. What do you understand the mass to be? See, again, this is just, it's this simple, okay? I've made the analogy. You're not attacking it. You're not conceding it. You're not recognizing it. That all this is about. The mass is the foundation on which you're carrying your velocity. The more mass you have, the lower your velocity, right? Well, let me just keep these two obviously different. If I have a little mass and I pour, the velocity in, obviously the velocity level is going to be much higher than if I pour the same velocity into this mass. It's going to be much lower. Okay, it's the same volume of velocity, the same energy is in here that's in here, but obviously it's going to read on this scale as different velocities. But that's all it is. That's all velocity is. Yeah, lighter things convert energy into more velocity. They end up filling the test tube fuller because of their small amount of mass. So they accept the energy, they coat the mass with more, and it goes higher, and you get a bigger reading in terms of velocity. But it doesn't change the volume. The volume here is going to be exactly the same as the volume there. Shit. Really, I'm just saying, you can't understand that? That metaphor, that analogy works. It's a very good way to explain what happens, that you have to give pieces of matter the velocity, and the more pieces of matter you have, the less velocity you can spread on them with a certain amount of energy. A certain amount of energy can only coat the surface so thick. It's like putting paint on the wall. the less surface I have, the thicker the paint is. The more surface I have, the thinner the paint is. And we could just use the thickness of the paint as an analogy for velocity. And that's the way it always works, and it works. The fact is that analogy works in describing the real world. All right, there's also the mass to consider. In elastic collision, so again, this has so little to do with any of this elastic or inelastic stuff, because we know that everything is partially both. So there's no use comes in this. We're just saying whether you're going to transfer the energy or whether the object won't accept the energy. Okay, and that's part of the thing. They can't stay connected to each other. And that's a whole different science about why they would if you don't move something, then obviously the energy's still in it. If it's not moving, it means the energy isn't working. Okay, it went in, but it's somehow not making it move. So the energy can't stay. It can't turn into nothing. The energy either has to move the object or it has to go back that way. All right. Also, there's okay, in an elastic collision, things stick together. Duh. I mean, really, duh. The velocity decreases, but the mass increases. So, again, he's just playing this game. Again, we're talking about the transfer that creates that circumstance. There's no automatic that any of this happens. This has to happen through a process of connecting things. In the trains, it only really works, right? If you're hitting the light train into the heavy train, it only works if you couple them. So you have to force them to be inelastic. You have to force them to stick to each other. And you're basically saying that somehow in forcing them to do that, you lost half the energy, which is preposterous, because you have no evidence of it. And again, that experiment I can show you. I can show you that people dropping weights on trains and doubling their mass and getting half the velocity out, nearly half, within the margins of a few percentages. All the momentum is successfully transferred. You're saying half the energy was lost. Clearly, you have nothing to defend that with, again, except some silly notion in your head, where you're going to tell me you actually believe the 10-ton train going 5 miles an hour, if I put a generator on its wheels, I'll get 1/2 the energy that I'll get if of the 5-ton train going 10 miles an hour. Somehow, the lighter train going faster will turn the turbine more. And you've got to know that's wrong. That's like saying a water wheel. If I take less volume of water, making it go faster, that has more energy than the bigger stream going slower. Do you really think so? I just can't believe you really think so. All right, the velocity decreases, but the mass increases. Again, the mass didn't increase. You obviously added a mass to a mass. So, which will preserve the momentum. Preserve what? How can you preserve momentum and then say that's not its energy? Of course that's its energy. The energy is the momentum. What are you calling? What is momentum if it isn't a description of energy? Again, what use is using the word? It doesn't make any sense. Oh, man, whatever. I mean, your last comment glibly stepped right past that problem. You have no rational purpose. There's no rational purpose for momentum in your universe once you've accepted this silly mv squared nonsense. Another thing is the reference frame. So this is just such horseshit, and I've been over this one too. It makes no difference. We know that we can change the whole universe anytime we want to and make some silly rule that the whole universe is going this way. So yes, everything in the universe now, this thing is also going this way because it's not moving. And this thing isn't moving, so it's going that way. And obviously a thing that's not going that way would look like it's, from our perspective, it's moving against us, even though, well, it's just going with the universe. Or it's not going with the universe. So it doesn't matter whether the two things, it doesn't make any difference to the fact that we know the two objects have to have opposite. One of them has to have either 100% of the movement going this way, or this one has 100% going this way, or they have some, this one's 20% and this one's 80%, or we just change the percentage of the motion. But we know there's 100% of the motion is opposed. So it doesn't matter whether the whole universe is moving this way, so this thing's moving 0 and this one's moving 100 miles an hour this way. It doesn't make any difference. I'm saying as a fact it makes a difference, because I'm saying these objects will get changed. The faster and faster you make them going, they're going to break. But it doesn't matter for all these common, road type scenarios. Which car is actually going the difference. It doesn't matter whether, if the collision's happening at 30 miles an hour, with the total opposite velocity is 30 miles an hour. It just doesn't matter whether one of them's moving the full 30 or they're both going 15 in opposite directions. It doesn't make any difference. It doesn't make any difference to these, to understanding the energy change. I would say that it actually physically does make a difference, and there probably will be someday experiments found that will be able to show that difference. That the one that has the actual speed is going to be differently affected than the one that doesn't. All right. So anyway, reference frame. So this is just where they bring up this horse shit of trying to make it of relativistic. Let's see if I can make the universe disappear through relativity. It's just such a diversion from anything reasonable. Anyway, when you drive next to another car at the same speed, your momentum and kinetic energy is 0. So again, it's 0 compared to what? No, it isn't. Everything's really moving in the universe. The Earth is really moving around the sun. We're really moving on the surface of the Earth. All this stuff is really moving in a sense of it's moving relative to other stuff. And there's no doubt about the fact that they have a different vector in three-dimensional space. So it's just silly to sit there and say it doesn't have any momentum. How do you know? It clearly has. We all have momentum going through space. The sun's hurling through space. We're going around it like this, hurling through space. These are realities. So either space is going this way, there's an ether wind and it's blowing against us, or we're physically actually doing the moving. But you can't have it both. You can't have it like nothing's moving. No, everything is. Something's got the real velocity. The fact that we are trapped by our relative perspective, the fact that we can't see it from the true quiet place in the universe, because we can't establish a control where there is no movement and therefore see all the relative movements as actual movements, doesn't change the fact that we can understand it. Oh, whatever. It's just, this is where, he's just talking about the lineage of the Holy Ghost here. I mean, this is just all so made up. All right. Your momentum and the kinetic energy is 0. So it's just silly to say you established how much kinetic energy there is. I mean, obviously, if we're moving the same way, we have exactly the same biases. That's all you would say. There's no differences in our biases. Whatever energy we have, it has biases in exactly the same direction. So there's no conflicting directionality to our vectors. Our energy vectors are consistent with each other, the same. And so there's nothing to have a conflict with. There's no interaction, that's inevitable. Without friction and air resistance, you could go on forever without using any fuel. So again, duh. I mean, I'm not challenging anything like that. And I'm obviously making the point that, I would challenge it in the sense that I don't think the universe is that empty. So you'd really need a more perfect universe than we have. But yeah, I'm the one saying that you possess the energy. You have the fuel, just like rocket fuel. You have it. All right. Now, once you get to coasting speed in space, you can have a full tank of rocket fuel and you never have to use any more of it because you're coasting. All right. Keeping the same pace doesn't require energy. Yeah, exactly what I just said. So you could go into space with a half tank of, you could use half your energy to get into space to defeat our gravity, Earth's gravity, get up to a velocity where you defeated it. And as long as you navigate through space without getting caught in any gravity wells, you can do just fine and still keep your half tank of gas. Not under ideal circumstances. Okay. Keeping the same pace doesn't require energy. Not under ideal circumstances. Yeah. If you want to move slower or faster than the other car, you have to burn fuel of course, but not otherwise. Well, if I want to move faster or slower, if I want to move faster, I don't have to burn any fuel, right? I can just create brakes. I can just, I can steal some of my velocity using some other available force. Okay, but we're saying, okay, in this circumstance, you're not allowed to brake against a road, and you're not allowed to skirt closer to a planet to, have some of your velocity stripped off by gravity. So yes, you have to burn fuel thrust. You have to give away your momentum. So again, these analogies aren't going to show any distinction between our theories, frankly, because my theory perfectly explains these circumstances. All right, momentum perfectly deals with this. So you're not showing where you're going to demonstrate that there's some necessity for the existence of this mv squared nonsense. On Earth, where most of us spend our entire life, we never see the ground moving, so this is our fixed reference point. Well, the point is we don't see absolutes. We don't get to see something. Nobody can poof into existence right here in front of me, absolute not moving. So here's some matter in a little cube, and it's not moving in the absolute universe. Now, the fact is that we're not going to see the cube very long, right? Because we're going to zoom right past it, some direction. We're either going to zoom away from it or zoom right past it, because we are moving. All right, to us it's still why we move around, but of course the planet is moving as well. Something not having velocity is an illusion. Something not having velocity is an illusion. I think that's the wrong way to say it, but I would just say that something in the absolute frame. So again, there's nothing about Einstein's theory that says there can't be an absolute frame. There's nothing about Galilean relativity anyway that says there can't be an absolute frame. You're the one breaking logic here by attempting to argue the three dimensions don't exist. And I think that's really pointless. But frankly, it really isn't related to the story of why you have an mv squared. You're asserting that the 10-ton train going 5 miles an hour produces less energy, that it's carrying momentum that has less value, that somehow it's a degraded momentum, that it's not capable of knocking down the same amount of shit. That if I plow the two trains into a building, one of them will give the building, will give bricks, will give the particles of the building more movement. That if I count the movement created by the two trains crashing, and I count each little piece of movement, that somehow the faster one is going to create more movement. And you have no logic to defend that. And you certainly don't have any experiments to defend it. All right, in space... In space, things are always moving. In the universe, everything, okay, there's probably something in the universe that isn't moving, but yes, we can't tell the difference. Relative speed is the only thing nature cares about. Well, obviously, I wouldn't even say it that way. Obviously, crashings, vectors are all that nature cares about. All it cares about is that your trajectories have to have opposite biases. So you have energy in you, and your energy isn't like a perfect sun. You're not going in every direction equally, let's say. Okay, so if light was what moved the sun in the universe, and right, it's not, but if the light coming off the sun is what moved it, it would end up moving nowhere, because it's shooting equal amounts everywhere. So it doesn't go anywhere because every direction is the same amount of energy. And all you're really saying is that, no, we're not like that, though. Our energy wasn't coming from inside of us. It came from interactions with the external world. Interactions with the external world give every piece of the earth has a history. Every piece of the earth got to the earth with vectors of velocity. Every single piece. And that's what's decided what the Earth is as a moving object through space, is what it's interacted with. What bowling balls hit it. And we're just saying, well, instead of we're like a bowling pin, but instead of getting hit with big giant bowling balls, we've gotten hit by billions and trillions of little bowling balls. And that's decided what our vector is. and also a combination with the other things we're interacting with. So obviously the sun is controlling it by having a mass and creating gravity. All right. So anyway, just not even close to responsive to anything. Okay, I said in the video. Just like it didn't happen. Like I didn't point out clearly what Lewin said was wrong. Now you could just say, yes, you're right. I mean, too many physicists, 1 minute they're mocking how silly people are to think, well, rockets need air to push against. And then they'll show an example where they'll just say it overtly. Here's a balloon. Yeah, the air goes out this way and pushes against the air. No, it didn't do that. So, whatever. It's just hopeless, communicating with humans. Apparently, So this guy, Jeff Hu, sort of agrees with me, but I don't know where he's going either. He has his own little stuff going on, I think, in terms of how he's looking at things. So I'll read this and just point out where I diverge. This is exactly correct. It's really just breaking of the equilibrium. And again, you really don't have equilibrium. You just have a different equilibrium than something else, in the sense of you have a different biases. Different biases are what hit it. You have to have a different bias to hit something. Okay, if you have the same bias, then you don't hit anything. But we're all carrying something other than equilibrium, in the sense that we're all are in fact moving every millisecond. Our vector in space changes. Which way our bias is in the universe, in terms of the absolute universe, which way we're moving is constantly changing. Every millisecond we're going some new direction. Part of the problem is there is much about equilibrium and force invoked in everything, which is something most people fail to think about. No, what they're failing to think about is that the energy is like paint, and you can pour it from one bucket into another bucket, into another bucket, into another bucket. And when you pour it out of your bucket, you don't have it anymore. It's a commodity that is exchanged, and it's given. And velocity is just one half of the mixture. The mass moving is just as important as the moving. The mass part is as important as the moving part. The mass is what gives the energy any meaning. If you don't have any mass, you can't hit something. It's not possible for you to interact if you don't have the electrons to bang into the other electrons on their surface. If you can't bang into electrons, you can't transfer your energy. You can't transfer your motion. Okay, if they were to realize that matter is a collection of forces, see, that's the part that I just, that's not exactly what matter is. I mean, obviously matter is charge. Matter is electrons and protons. It's charge. And charge is a bunch of the elements of photons. Charge is a bunch of little bits, okay, bouncing between these parts. Ping pong balls trapped between ping pong paddles. That's what charge is. And so that's the part where all the energy is in the ping pong balls, keeping the electrons and protons from just falling into each other. All right. Let's see, forces. They understand reality and momentum more accurately. If they were to realize that matter is a collection of forces with directions. Okay. Yes, see, you can't say matter is, because matter is electrons and protons. So you have to say atoms are, that large material objects have trapped within them energy biases, force biases, directional biases. They have more stuff going this way than they have going that way. All right, they'd understand the reality of momentum more accurately. It's number one basic critical step towards understanding gravity. See, who knows? I'd say it's obviously, in my opinion, gravity is again violating one of the basic laws of physics, that is energy conservation. Because the fact is that in some sense gravity destroys some energy, because it takes forces moving the speed of light and converts them into forces moving slower than the speed of light while it's pushing matter. So the fact that pushing matter does consume energy in the universe would be a really important fact for people to realize. I mean, it's really an important fact to realize. I mean, it tells you an awful lot. It also tells you that the more the universe has more external energy, the fewer bits that are trapped between matter bits. So the more I scatter the matter, the more energy the external universe has to apply to compress the universe. So gravity increases as you do this, as you cool the universe, as you heat the universe. Yeah. The way they teach and build into physics really is like Frankenstein analogy. Well, the fact is that all science, all investigation, our whole history on this planet is a Frankenstein experiment, in the sense that we are already stuck with, abnormal brain, as to start with. But I mean, we have to build on the stuff that's already there. You just can't, you can't start over. You have to build on it. Like, you do something one day and then you come back to it a week later, and you have to, nobody restarts when they find out, hey, this leg is shorter than that leg, and they're not going to do the hip bones until, it's cobbled together. It's a monstrosity of putting things on top of, putting new ideas on top of old ideas, and some of them turn out to be completely wrong. So all of Maxwell's equations are kind of screwed up because they never fixed plus and minus. I mean, those kind of simple problems where, they just, if you don't fix it at its foundation, you end up with a building going in all kinds of crookedy directions. And so, yeah, it's a monstrosity. But this part of this argument is so isolated, in the sense that you can just see how completely superfluous to good function in science this theory was. There was no good reason for any scientist to say, yes, momentum's broken, let's fix it. There was no evidence momentum was broken as a definition of energy. Just none. Newton did really, really well in describing a lot. And there's just no evidence that any of what Newton did needed to be fixed because he was calculating wrong. No, he was calculating correctly. And this just breaks all of that. And again, that's why NASA says we just use Newton's physics. It's because they're basically saying, no, we don't do this. We don't. Because it won't work. It won't be rational for us to think when we're in the spaceship, we shot 2,000 joules out this side of the ship because we let a dime go, 1,000 miles an hour. And we only shot 4 joules out this side because we moved 2 kilograms 1 mile an hour. The NASA scientist knows, damn it, those are the same events. They're not different events. They don't have different amounts of energy. Those are exactly the same thing. I gave away 4 joules over there, and I gave away 4 joules over there. It's not 2004. That didn't happen. That's just a silly fable here. That's just so wrong. It's obviously so wrong. And again, so why don't you deal with that one thought experiment, Jerry, and explain how you can make any sense out of it. I gave the universe 2,000 joules this way, and I only gave the universe 4 joules that way, or 3.5 or something. 2.3, really, by my calculation. What happened to the spaceship, and isn't that free energy? Because I didn't use 2,000 joules to launch it. I only used 2.3 joules. Well, whatever. I mean, you people are just intractably hostile to the truth. So this crap, I don't know who this Christian Thompson, so I'm just going to block this guy again. I have just 3 things to teach: simplicity, patience, and compassion. Just baby talk, absolute baby talk. Everybody thinks their answers are simple. Everybody thinks they're patient. Everybody thinks they're compassionate. What is this? This is just baby talk. Let's see. These 3 things are your greatest treasure. Bullshit they are. Too much of any of that crap doesn't get you anywhere. So, to be too patient, you end up dead. You be too compassionate, you'll end up broke. I mean, none of this can go anywhere. So, yeah, take this babble elsewhere, silly person. Ugh. So this was the guy who accused me of blocking him. Alright, I guess I'm not blocked, so that's good. I apologize. And based on recent discussions, only the Stephen Bro video has been presented to support their assertions. Yeah, and Stephen was talking like, oh yeah, I got a whole bunch of extra stuff. I got all this evidence, blah, blah, blah. Nothing showed up. It's been like 3 weeks. Not a single peep of any of this. I'm going to back up what I've done and show you how great it is and what great integrity my experiments have. Why hasn't any of that shown up? Oh, because maybe he figured out that maybe some of his experiments were a bit flawed. Even though he's clearly a heavily biased source and has done none of the proper documentation for his experiments. Well, yeah, let's just trust him. Hey, it's half the velocity. Trust me. Yeah, I don't think so. Experiments are supposed to be done so they can be repeated and verified. That's at the core of the scientific method, detailing the mechanism, materials, and the procedure, and how many times each experiment was performed, actual data, etc. Yeah, it's even that block of wood experiment that I showed. I mean, the guy could have done that so much better, right? If he just took a little bit more time, it would have, some kind of real value. If he would have figured out what the friction coefficient was and some different things, would have just added value. None of this has been done. Also, the implication is that the kinetic energy formula was never experimentally proven until this 2021 video with highly questionable experiments that cannot be verified. Well, it just is sort of funny that these people are making this claim that this theory has some integrity, and there's obvious experiments you could do where you just collect the energy. Just take the 5-ton train and smash it into a spring. Take the 10-ton train, smash it into a spring, see how much energy it has. How come they haven't done any of these experiments to show me that it has twice as much energy? That somehow velocity makes a difference when I collect the energy with some reliable method. And all they'll do is say, well, in clay it works. Yeah, and I can question clay. I can point out that, well, clay is a really bad example because that one has a bias for velocity. Duh. I mean, it's just terrible. Not sure how they can justify this. They can't justify it. All they can do is troll and, try to blow up the conversation because clearly they're going to lose the argument. They're on the wrong side. They got to have some kind of cootie feeling inside of them saying, yeah, this just isn't right. I mean, if this was true, I'd have evidence of it. Why is there no evidence? Why can't I prove it to him? Yeah, well, you can't because it's not true. That's why you can't prove it to me. All right? This because it seems totally absurd. But I'm still patiently waiting for any new physical evidence to be presented. Yes, and we're all going to have to, like I said, the piece with the wooden blocks eliminates some of their notions, right? I mean, the wooden block thing is just basically, like I said, it's in slow motion enough as there's enough visual insight provided in that if I, take it and slow it down even further, it can be shown that no matter what the weight is over here on the elastic band, no matter how many blocks I stack up, this thing's velocity is always the same. It just has to travel further to get to the blocks. So, all I'm changing is the distance it travels at that velocity. So, yeah, it might slow down a little bit more because it's going further, more friction. But the fact is, it goes the same speed each time. It's going the same velocity, same velocity, same velocity, same velocity. It doesn't matter what's over here. Because what's over here has got the same momentum. Moving 5 blocks, I can't move 5 blocks fast. I have to move 5 blocks slow. It's the same momentum here as there is here, and there's always the same momentum on both sides of that elastic. And that's proven. So they can't use this silly 1/4 of the speed crap. They can't make up all of these fake things to somehow rationalize their very bad math. Ugh, shit. Yeah, so that's it. I don't know. How did this... What? Yeah, now it does videos again. I don't know. It's just really strange. Alright, so anyways, that's enough. I think. It's enough for me anyway. Just very discouraging. You know, I mean, 230 views, 9 thumbs up. I mean, 9. So only 4 out of 100 of you people are getting any of this. 4 out of 100. Only 4 out of 100 people think it'd be a good idea to point out when Professor Lewin is saying something totally inconsistent with his physics. He knows better. He knows there's no equal and opposite reaction created by the external universe. He knows. This guy flew in balloons going way up in the atmosphere and shit. Well, I don't know if he actually went in the balloon, but whatever. I mean, he knows, you know, the spaceship can only use what it has to give away. It can't use something else. And so it's not pushing against something to move. It's giving away something to move. And what it's giving away is obviously things moving in a direction. It's spilling its paint. It spills some paint that way. Okay? That means it still has paint going this way. And that paint now is stronger because it gave away this. If you have this, and I give away this, then all I have left is this. Obviously, I'm going that way now. When I have this, I can go this way, you know, and I'm going fine. Everything's just fine, right? I'm going a nice straight line because I have the same amount of this and the same amount of that. If I give away this, then I have a bunch of this left over. Come on. He knows that. So why is he making up this crap that the equal and opposite reaction comes from the environment? No, it comes from you giving your paint away. Shit. All right, that's all. You know, like I said, all I can do is reason with you. I'm sorry. I'm disappointed. You're dumber than I thought you were. The human race is really, really stupid. And like I said, if the aliens ever do test us, we're doomed. Because your people are just way too stupid. And I'd say, you know, frankly, you're doomed. I would pay the aliens to come here to blow the planet up, frankly. I would pay them. I would, you know, I should make a little bottle rocket to send into space, you know, asking the aliens, please, please, please blow us up. Just too stupid, too sucky, way too frankly retarded. Just we're beyond reclamation, and it's way past time. Anyway, and fuck you, generally speaking. All right, so this has been a Draft Science video presentation. I will endeavor to persevere, but man, it's tough.